This is the 1-3 Properties of Numbers practice. And it would be handy to have your vocabulary page from section 1-3 because it identifies and explains all of the properties of numbers that it will ask you to use. So, in the first part, it asks us to evaluate each expression and name the property used in each step. So like I said, if you have your vocabulary worksheet from section 1-3 handy, you'll have all of the properties of numbers at your fingertips. So number 1, we have our order of operations, which are following. Which goes by, please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. So first we do what's inside the parentheses, and then inside the parentheses we also follow order of operations. So 3 squared is what we're going to do first, and that is 9. And we can do that by substitution. Which I'm now going to call subs for short. And then we have to finish what's inside the parentheses before we can do anything else. And 9 minus 9 is 0. And that property is called the additive inverse property. And what that property says is, if you have a number and you add its opposite, and the opposite of 9 is negative 9, then it's 0. Well, that's just the same thing as subtracting a number when you add a negative like that. It's the same thing as subtracting. So when you see a number minus a number, it's going to be the additive inverse. After we're done with the parentheses, we can move on to exponents, which we don't have any more of. Then multiplication's the next one. So 6 times 0, and that's going to be 0. And the property that tells us that anything times 0 is the multiplicative property of 0. Which I will write as mult prop 0 from now on. Then we move on to addition, subtraction, and we move from left to right. So 2 plus 0 is 2. And the property that tells us that anything plus 0 is itself is the additive identity. Which I will do as add ID from now on. An identity means you're getting the same number back. So when you add something, which is 0, to a number, you get it back. And then again, we see 2 minus 2, just like we saw up here with 9 minus 9. So that's going to be 0. And that's going to be by the additive inverse. Number 2, we do what's inside the parentheses first, and then inside the parentheses the division comes first. So 39 divided by 3 is 13. And that's just a substitution, it's what it equals. Substitution property says that if something is equal to it, you can just substitute it or replace it in the expression for that thing. 39 divided by 3 is equal to 13, so I can just substitute it in there. Then we finish off the parentheses. 14 minus 13 is 1. and that's another substitution property, because 14 minus 13 is equal to 1. I can put it in place of it. Then I don't have any exponents, so I move on to multiplication division, and the first one is 5 times 1, which is 5. And that is the multiplicative identity, because when I multiplied, I got the same number back. So that's the multiplicative identity, which I will write from now on as mult ID. Then we have 4 times 1 over 4. Well, 4, if you were to write it as a fraction, is 4 over 1. So if you notice, the fraction 4 over 1 and 1 over 4 are opposites. Well, they're flipped over. Those are called inverses or reciprocals. And when you multiply reciprocals, you get 1. So 4 times 1/4 is 1. And that is because of the multiplicative inverse property. And then the last one, 5 plus 1, is 6, and that's just a substitution. In number 3, it says evaluate each expression using the properties of numbers. Name the property used in each step. And 3 and 4 are going to focus primarily on the commutative and associative properties. And those two properties say that the order that you add or multiply in does not matter, and that you can group them in parentheses and do addition and multiplication whichever way you want first. And the whole reason behind that is to do quick mental math. So when I look at something like this, I see 13, 23, 12, and 7. When I see a 3, I want it to end up adding with a 7 because that'll add nice and neat. So I could either do the 13 with the 7 or the 23 with the 7. It doesn't matter. Since 13's first, I'm going to put the 13 and the 7 together. So I have 13 plus 7 plus 23 plus 12. So I'm looking for things that add up to nice, easy to work with numbers, which are typically 5s and 10s. And the commutative property is the one that allows me to rearrange things when I'm either adding or multiplying. Now, I'd like to do this 13 plus 7 and this 23 plus 12 separately at the same time. So I'm going to put them in parentheses so that by order of operations they would get done separately and not have to go from left to right. And that is allowed by the associative property, which says I can group them in any way when I'm adding or multiplying. This is not true when you're subtracting and dividing. So now 13 plus 7 is 20. 23 plus 12 is 35. Had a little brain fart there. And that's just a simple substitution. And then 20 plus 35 is 55. And that's another substitution. In the next one, I'm going to look for something that, again, makes a nice even 5. The problem is I have a decimal with my 0.7. But I know that if I multiply 7 by 5, it's going to end in a 5. So I'm going to put brackets around the 0.7 and the 5 so that I can do those before I multiply by 6. So I'm going to do 6 and then parentheses 0.7 times 5. And that's the associative property, which says I can group them in any way. I'll abbreviate it with a ASSOC, associative. Now, when you multiply by a decimal, you can just ignore that there's a decimal there to begin with. So 7 times 5 is 35. Then I go back and I look. Well, this really had one spot of decimal, so then I have to have one spot of decimal. So right here, I would move it over, and the answer would be 3.5 for 0.7 times 5. So 3.5, and that is the substitution property, because 0.7 times 5 is 3.5. So now I have 6 times 3.5, and I'm going to borrow a little bit from the distributive property, which is the next section, but we've already worked with it. So 6 times 3.5 could also mean 6 times 3 plus 0.5. 3 plus 0.5 is equal to 3.5. So by substitution property, I can do that. And then the distributive property tells me to multiply the 6 by each thing inside. So 6 times 3 plus 6 times 0.5. That's the distributive property. Well, 6 times 3 is 18. 6 times 0.5 means half of 6, which is 3. So I end up with 21. So that's a substitution. And then that equals 21, which is a substitution. So the whole point of the commutative, associative, and distributive property is to be able to do this mental math stuff and not immediately reach for your calculator. All right, the first word problem says, Althea paid $5 each for 2 bracelets and later sold each for $15. She paid $8 each for 3 bracelets and sold each of them for $9. Write an expression that represents the profit Althea made. Well, when we're talking about profit, it means she paid this much and then sold it for more. So I want to find the difference between what she sold it for and what she paid for. So for the bracelets, she sold it for $15, but we'd have to subtract off what she originally paid for it. And then I'm going to put it in parentheses because there's 2 of those. So there's 2 that she basically, if you do 15 minus 5, it's going to be 10. So she made $10 each on each of the bracelets. So $20 for the pair of them. And then if we add on, we want to find out how much for each bracelet she made that she sold for $9. Well, she sold them for $9, but she bought them for $8. So basically she's making $1 profit on each, and then there's 3 of them. So in the next part of the problem, it says to evaluate the expression. So the first thing that I would do is just show that she made $10 and $1 each on the respective bracelets. So I would say 2 times 10, because that's 15 minus 5 is 10, plus 3 times 1, because 9 minus 8 is 1, and that's just a substitution property. And then 2 times 10 is 20, and 3 times 1 is 3. The 2 times 10 is a substitution property. And then 3 times 1 is the multiplicative identity. Anything times 1 is itself. And then the last one, 20 plus 3 is 23. And that's a substitution property. And since this is a word problem, we know there should be some units to go with it while they're talking about profit, so dollars will be our units. All right. Number 6, last problem of the page. Kristen purchased 2 binders that cost $125 each, 2 binders that cost $475 each, 2 packages of paper that cost $1.50 each, and 4 blue pens that cost $1.50 each, and 4 pencils that cost 35 each. Excuse me, $1.15 each. So, if I write this all out, it would look like she bought 2 binders that were $1.25 each, and she bought 2 binders that were $4.75 each, and she bought 2 packages of paper that were $1.50 each, and 4 pens that were $1.15 each, and 4 pencils that were 35 cents each. So that's one way that we can write the cost. The other way that we can do is to look at it and say, well, we have a common factor of 2 in each of those 3 things, and a common factor of 4 in each of those 2 things. So we can do the reverse distributive property and say that we have 2 times 1.25 plus 4.75 plus 1.50. And then on top of that, we would add the rest. Outside, we have 4 times 1.15 plus 0.35. So, from here, I can start to try and figure out what it actually cost her. So, inside the parentheses, I do 1.25 plus 4.75, and conveniently enough, they're going to add up to a nice even dollar. 1.25, I take the 0.25 and put it on the 4.75, that gives me 5, plus 1 is 6. Then I have 1.15 and 0.35. Well, 0.15 and 0.35 add up to 50, so I have $1.50 there. Still have parentheses in the red. 6 plus 150 is going to be 750. And then we still have 4 times 150. 2 times 750. Well, 2 times 7 is 14, and then 2 times 50 cents is 1. So I have 15. And then I have 4 times 150. 4 times 1 is 4, and 4 times 50 cents is 2, and 4 and 2 is 6. So then my final answer, 15 plus 6, is 21. And again, this is a word problem. I look back, we're talking about the total cost. So the units are dollars. It costs her $21.